Yes, ma'am. Yes, ma'am. Thank you. So, good morning and welcome everyone. Thank you for joining us for today's session. My name is Shruti Barguzar and I'm a third year computer science student. And I welcome you all on the behalf of GH Raisoni Institute of Business Management in Jalgaon and the Department of Computer Science and Information Technology, Artificial Intelligence and Data Science. Today we'll be having an expert talk on fundamentals of digital image processing and image enhancement in special domain under Center of Excellence of IoT and Python by Dr. Mukesh Patel. Just a little housekeeping before we get started. If you have any question during the presentation, please type them in your chat box. I'll bring them up during the presentation and we'll also have the question. So I'd like to introduce you to our expert of today's.
Okay,
Yes, sir.
so let me present my presentation. Yeah, is the slide visible, everyone?
Yes, sir.
Okay, so first of all, I am very much thankful to Madam and her colleague for giving me an opportunity to interact with such a enthusiastic youth in the data science and artificial intelligence, as well as computer science and engineering. So, as Madam has discussed about mathematics, a foundation of each and every course or syllabus, yeah, definitely. If you go with the digital image processing, before we go on digital image processing, let me tell you something about data analysis. Data, when you go for experiment, when you collect the information, it is always in the form of quantitative data. Whether you go for signal processing, whether you go for sound processing, and same you are suppose going with digital image processing. So when you have a quantitative data and suppose you want to deal with those quantitative data and suppose you want to analyze it, you have to go with the basically some of the mathematical tools are very much useful, like statistical analysis, the foundation of this particular data analysis, numeric analysis, operational research. And if you go beyond that, and suppose the data have a multidimensional data you are getting, and suppose you want to deal with the multidimensional data, then you have to prefer uh, neural network, genetic algorithm, fuzzy logic, that kind of algorithm we have to follow to analyze the data. So neural network and genetic algorithm and fuzzy logic, this all belongs to the soft computing. The basically, it look like a computer version. Fuzzy logic or
Sir.
genetic algorithm or neural network or digital image processing, it look like a computer version, but it is a fundamental it's a fundamental mathematics. So if you really want to deal with those models, whether digital image processing, signal processing, sound processing, or any artificial intelligence.
Hello, sir.
Yes. Yeah,
Sorry
yeah.
to interrupt, sir. Your PPTs are not visible right now.
Wait a minute, just a second. Is it visible now? Just a second. Huh? Let me share a window only. Now is it?
Yes, sir. It is come.
Yes, sir. Screen is visible now.
Yeah. So these are look like a computer subject, but if you have a good control on mathematics, you can easily deal and you can do much more thing in this field. So I will give little bit touch of mathematics to this particular topic. So yes, digital image processing. Today's topic is fundamentals of digital image processing and image enhancement in spatial domain. Image enhancement includes so many things. Image transformations, smoothing of image, sharpening of image, morphological image processing, and so many things are there. But today we are talking about only some of the concept of image processing with practical approach in spatial domain. Once we will also discuss what is spatial domain, and when we transfer or when we apply the Fourier transform that you have already learned in engineering also. When you apply the Fourier transform, we will talk about here discrete Fourier transform in a discrete version, not continuous version. So we will apply Fourier transform and we convert this image into spatial domain to frequency domain or temporal domain. So this is another concept. So see, let me start with today's session with basic fundamentals of image formation human eye. So as usual, uh, image is nothing but what we see, what we observe, what is the vision, and how this vision is digitalized. There is a two system. One system is given by the nature, just like our human eye is performing a digital image processing. And similarly, on the basis of that concept or phenomena, the scientists have developed an artificial system that is called digital image processing. So the same concept or same phenomena applied in human eye, the same thing is converted into artificial form called as digital image processing. Okay, so the basic concept says that image is nothing but source of light. Image is nothing but source of light, and one of the ultimate source of life or illumination source is sun for we people or for the earth. So sun is an illumination source. When the light is coming from the sun to a particular object, say a tree, and when it is reflected from the object, and when it enters in our eye, there is something happen inside our eye such that we can observe that object. And the major role performed by some of the component of human eye like ciliary body, retina, lens, so many things are there. So yeah, and whatever pictures is created on retina, which is visualized by the nerve system, passing through the nerve system to our mind, and our mind is imaging that particular vision. So ultimately, it is a source of light only. And when we talk about source of light, there are so many types of lights are coming from the sun, whether it is a radio wave, microwave, infrared, visible spectrum, ultraviolet, X-ray, gamma rays, and every light has its own frequency, varying between some interval. We will see later, but they have some frequency, and they have their own applications as well. But we are today talking about the visible spectrum of this electromagnetic spectrum. So what is visible spectrum? See, you know that the wavelength, frequency, and energy, all three are the component of light. And if we talk about radio wave, you can see that it has a low frequency. And we will go ahead from radio wave to gamma, then you have a high frequency. Sorry, I have a high frequency. Here you can see. If you talk about visible spectrum, so visible spectrum is nothing but the combination of three colors: red, green, and blue. Actually, we are talking about rainbow. There are 7 colors, not only 7 colors, these are the basic colors. But if we take the combinations of basic 3 colors, red, green, and blue, you have a many more colors. Okay, and the visible spectrum is we can say its frequency is varying from 7.5, or you can say 4.3 to 7.5 into 10 raised to 4. So here, if you talk about nanometer, then it is 400 to 700 nanometers, in which our eye can visualize the object. which doesn't mean that there are no other lights are available. Yeah, there are other lights are available which has a more frequency, which having less frequency, but our eye has no capacity to visualize them. So whatever beauty, whatever nature we are enjoying, whatever object we are visualizing in the region of this visible spectrum RGB. So if you see the diagram, there is it's a huge spectrum, but out of that we have a very small spectrum of visible range in which we are enjoying the life. Right? So what this spectrum is, it is a combination of colors, and three basic colors are red, green and blue. Now, how our eye can visualize the colors, how our eyes can visualize the dimension of object, colors of object. There are some kind of sensors inside human eye. Basically, there are two types of sensors. One is called as rods and second is called as cones. So cones and rods are the basic sensors available in our human eyes, and both having their own functionality, right? Cone having the functionality of recognizing the colors, red, green and blue, basic colors. So cones are the sensor which can recognize the color of the object, and rods have a functionality of overall structure or shape or dimension of an object is recognized by the rods. In the center of retina, cones are available in high amount, and if you see the diagram of in a degree, suppose 0 is the center degree, the center of the retina, and if you go left hand side 20, 40, 60, 80 degree, if you go at right hand side 20, 40, 60, 80, 100 degree, at the center you can see the red line. It indicates the value of number of cells of cone. It is on a peak. That means the highest amount of sensors, color sensors available at the center point. 20 degree, the rods are in, so high amount of rod sensors are available on the 20 degree of the retina. So if you can see the data, then you can capture the high definition camera, high definition object with a low memory. So the technology is going to be enhanced, and you have a many more technologies in future through which you can deal with high resolution image. So if you talk about the sensor, artificial sensor in a camera, the same phenomena, the illumination source having light on a particular object, the light is reflected from the object, and we have an aperture in a camera. Every camera has an aperture in which what is the functionality of aperture? Anybody? Yeah, anybody can tell me what is the functionality of aperture? Aperture basically क्या करता है कैमरा में?
Sir, it's a point where light travels through.
Yeah, so it is a controlling parameter or controlling tool which control the lights entering in the lens or in the camera. So इसका बेसिक काम होता है लाइट को कंट्रोल करना, कि कितनी अमाउंट की लाइट आपको लेनी है अंदर, मतलब कैमरा के अंदर पास करनी है. If you have observed that when you click a picture on morning, at afternoon, at late evening, कई बार क्या होता है सनसेट पिक्चर कैच करने के लिए हम लोग पहुंच जाते हैं, but time has already been passed, sun is already been set. Then what happened? Light, the illumination source is very low, light आपकी low हो जाती है, and suppose you click a picture, you have a lot of noise. We will discuss later what is noise is, but you have a very low picture, low resolution or a low quality image. In such a situation, if the light is low and suppose you want to capture your pic, selfie, whatever you have, okay, so what you will take, you increase the aperture, such that the capacity of aperture such that you will get very brighter light. मतलब आप light को ज़्यादा अंदर कैमरा के अंदर insert होने देते हो, enter होने देते हो. In such a situation, you in a low light you have a very good and visible object or your selfie. Okay, so yeah, there is another sensor. In a human eye, we have a rods and cones. Similarly, there is a sensor is available, and this sensor has an output is voltage waveform, which convert your image into digital form. Okay, what kind of sensors are available? So there are basically CCD and CMOS. CCD is very older version. Maybe in a old mobile or camera they are still using CCD, but nowadays the CMOS are very much user friendly or advanced technology of sensor which have which is used in a different camera and mobile also. Now, since they have different types of sensor: point sensor, array sensor, point sensor, light sensor, line sensor, array sensor, circular kind of sensor. But here when we talk about the two-dimensional image, we are talking about an array sensor. So in CCD there are 4000 by 4000 element or more. So एक सेंसर के अंदर 4000 by 4000 जितने cells attached होते हैं. It is in a CCD. If you talk about CMOS, if you go to Google, you have a lot of lot of elements or cells are available in CMOS, which is a high capacity to capture the image with full HD or ultra HD colors. Now, how the image is digitalized? हम लोग पैरेलल जाएंगे थोड़ी थियरी और थोड़ा हम प्रैक्टिकल भी देखेंगे कैसे वो इमेज हम लोग उसको डिजिटलाइज कन्वर्ट करते हैं एंड मैथमेटिक्स भी वहां पे कैसे इन्वॉल्व होता है. सो बेसिकली the source is coming from illumination. Let it call as I of xy. Now reflection, when some amount of light is absorbed by the object and some amount of light is reflected by the object, reflected from the object. Here I want to ask one question to you. Suppose we have already seen one picture, some Hollywood movie or some Bollywood movie. Especially Bollywood movie is nothing but Mr. India. In some Hollywood movie also we have seen the person is becoming invisible, Mr. India, something like that. So my question is here, in which situation an object can become invisible? Anybody?
आउटपुट में सर.
In which situation किसी एक ऑब्जेक्ट, जैसे मिस्टर इंडिया में बताया था, the person is becoming invisible. So कौन सी ऐसी सिचुएशन होगी जिसमें सामने वाला ऑब्जेक्ट इनविजिबल बन जाता है?
Sir, when the dimensions of the object doesn't remains, like the object is having no volume or shape or size.
मतलब there is no existence of object. मैं तो ये कह रहा हूँ कि object is there. I'm talking you. Suppose the person is there, but it is invisible. There is a dimension. The person the object is there, shape and dimension is there, but it is invisible. In which situation?
Sir, we can say that if the object is painted or painted in such a way that it matches its background, like it is painted in green color and its background is also a green color cloth or something, so it matches and becomes invisible like that.
But at that time the background is also visible. Okay. For that we have to understand the concept of vision. यानी हमें उल्टा सोचना पड़ेगा. When an object is become visible, फिजिक्स में आता है, you have already learned in 10th standard or 8th or 9th standard. एक ऑब्जेक्ट विजिबल कब होता है? It only in one situation, when there is a light is thrown on that object, the light is reflected from the object, and when the light is entered in our eyes, then the reflected light is entered in our eyes, then it is visible. That means what, कि एक ऑब्जेक्ट के ऊपर लाइट गिर रही है सपोज, और उस पे से रिफ्लेक्ट होके हमारे आंख में जाए, and in that situation it is visible, otherwise not. So agar suppose the light is thrown on an object and suppose it is not reflected, the light is not reflected from the object, in that situation it becomes invisible. Is it are you understanding what I'm saying?
Yes, sir.
Yes, sir.
Okay, so now tell me, in which situation the light is not being reflected from the object, though there is a light is thrown on the object, but it is not reflected? Yes, in which situation the light is not reflected from the object?
Perfectly black body.
Black is also reflecting the light. Okay, let me tell you. There are two situations. One, first is all the lights coming to that object is absorbed by the object. अगर वो ऑब्जेक्ट पूरे की पूरी लाइट अपने आप में समा ले, नंबर वन सिचुएशन. और नंबर टू, द लाइट्स throwing on the object is passing through the object. That means वो ट्रांसपेरेंट हो जाए. जैसे हमारा कई बार होता है शॉपिंग मॉल में जाते हैं, द ग्लास इज वेरी मच क्लीन, द लाइट इज whatever light in a mall or are there, it is on the glass, but it is passing through the glass. At this situation the human eyes cannot identify whether there is a glass or not. In that situation ऑब्वियसली किसी को एक्सपीरियंस हुआ भी होगा, क्लास के साथ हम लोग टकरा जाते हैं, राइट? सो या तो ट्रांसपेरेंट निकल जाए वहां पे, देयर इज नो रिफ्लेक्शन, पूरा पास हो जाए 100% और 100% एब्जॉर्ब हो जाए. इन दैट सिचुएशन इट इज नॉट रिफ्लेक्टेड and not coming into our eyes, and in that situation the object become invisible. So फ्यूचर टेक्नोलॉजी देखेंगे, मिस्टर इंडिया में वो डिवाइस बनाया था, वो वॉच का काम ये है कि ह्यूमन बॉडी इज नॉट दैट मच ट्रांसपेरेंट लाइक अ ग्लास, बट द डिवाइस अटैच विद द बॉडी. कंसेप्ट है ये, कितना सही है गलत है वी आर नॉट टॉकिंग अबाउट इट, बट एक ऑब्जेक्ट ऐसा है कि वो लाइट को एब्जॉर्ब कर ले पूरे की पूरी, देन इट इज कॉल्ड it is become invisible. Okay, so yeah, so when the source of illumination light I of xy, reflection light is r of xy, coming from this object, entering from aperture, throwing on particular sensor, and it is digitalized in a matrix form. You can see here the matrix form, here the image, and every matrix having pixel. So image having pixel, and उसी पे से आता है megapixel, right? 1024. Okay, so megapixels camera. So here an image is nothing but a two-dimensional array matrix, or you can say that it's a digital image, and every pixel having some value. Now मैं मैथमेटिक्स में नहीं जाऊंगा ज्यादा, लेट मी कमिंग टू द डिजिटलाइजेशन ऑफ इमेज. सो पिक्सल वैल्यू, नाउ वी हैव ऑलरेडी डिस्कस्ड द आरजीबी कलर स्पेक्ट्रम. सो when the image is captured by the sensor and it is digitalized, then it is converted into two-dimensional pixel value. Now our human eye can recognize the pixel value having value maximum intensity 255 and minimum intensity 0. मतलब the pixel value between 0 to 255. Total how many values are there? 0 to 255. 256. And 256 is the 2 the power 2 raised to what is equal to 256? 2 raised to 1 2, 2 raised to 2 4, 2 raised to 3 8, if you go on and on, 2 raised to 8, 2 raised to 8 is equal to 256. That is why it is called 8-bit image. So are you clear with bits? Right? So when you convert your data 256, you need at least 8-bit 01111 जो भी होगा, that is called 8-bit image. Okay, so just a second, let me stop this particular presentation. I have to share my entire screen so that we can have 1 meter. Let me have okay. Now, can you see this screen of software MATLAB? Is it visible, everyone?
Yes, sir.
Yes, sir.
Okay. So there are some software which is, yeah, there are some software which is dealing with images. You may be aware with Python. Are you working on Python?
No,
Okay.
sir.
Have you
Yes,
heard the
sir.
word Python?
Yes, sir.
Okay. So basic software is something like, say, MATLAB. MATLAB is the most suitable software for image processing. Though it is a licensed version, so if you go with the open source version is Octave. Octave is an open source version. It is as similar as a MATLAB. So if you go with Octave, it is okay, or MATLAB. If you go more than that, you can use Python. Okay, so today we are talking about the MATLAB software, and we will see what happened with the image, right? So, are you aware with coding? Basic for loops and if loop, and you know how many
Yes, sir.
languages you have done? C, C++. Then how many languages you know?
Java, Python,
Java, Python.
C
So
Sharp.
it is as C sharp. Very good. So it is as similar as this particular language you have. Okay. So basic command I'm using CLC. That means it's clear the command. Okay. Let me talk about the structure. Here, this window shows the editor and script. You can write your code over here, and then you can run over. If you run it, you can have an output in command window over here. Here you have a directory. Here the variable, whatever variable you are taking, you can see in this workspace. There are so many windows also there, but basic 3 windows I am talking about. Now there are some command. I'm using CLC. CLC is a command which clear the command prompt. If I write CLC, whatever command prompt you have, it will be cleared in each run. Now, if I write clear all means what? Whatever variable will be stored in this workspace. इस workspace में जितने भी variable store होंगे, clear all करने पे वो every run time पे वो clear हो जाएंगे. Close all, I'm using the command for अगर कोई विंडो इमेज का ओपन हुआ होगा, जैसे हम लोग यहाँ पे ओपन करेंगे द विंडो ऑफ एनी पर्टिकुलर इमेज, राइट, देन उसको एवरी टाइम मुझे फिर से उसको रीओपन करना. दैट मीन्स एवरी न्यू रन, एवरी न्यू क्लिक पे वो सपोज इट शुड बी न्यूअर फिगर, in that time the previous one should be closed. So I am using close all. So these are the basic command that I am writing in the beginning. Okay. Now, how you can read, how you can insert an image into the particular software. There is a package. The package is called image processing, and the function is called IMRead. So IMRead, that means image reading. Okay. And when you type a bracket, the function says that enter the file name, and file name, whatever you have, into write into inverted comma. So I am using a very famous inbuilt or generally used image. You can use any image with the format. So here I am using Lena. There is a lady, the very inbuilt database. I'm using this Lena. The name of the person is Lena.png. Now if I run it, if I click on run, right, you can have an output over here. But It is a huge matrix. So let me run it. See, you can see some values. Okay, so this small window cannot display all this particular matrix. So what I'm going to do? Suppose let me show first. अगर मुझे इस फिगर को चेक करना हो, suppose I want to see what and a PNG format. Here in variable, you can see the workspace. Here a variable having 220 by 220 by 3 unsigned integer 8 यानी कि 8-bit image. यानी 8-bit image. 8-bit image, that means the value is varying from 0 to 255 यानी total 256. Why it is so? Because, just a second, huh? Okay, so yeah. If you are familiar with the Word document, can you see this Word document?
Yes, sir.
Okay, so if you go to the property, suppose fill color, more fill color, and if you go over here, you can see the window. Here, this cell having color, this, it is a combination of red, green, and blue, where the red value is 68, green value is 144, and blue value is 196. If I increase the value of red, कहाँ तक मैं increase कर सकता हूँ? Maximum.
255.
Only 255. उसके ज्यादा नहीं कर सकता. Similarly, green value I can increase up to 255 only. Why it is 0 to 255 only? Because if I use 255, 255, 255, अगर मैं तीनों component RGB are taking as 255, 255, 255, maximum पे पहुंचा दो, the cell of the color become white. The cell of the color becomes white. और उसके आगे हमारी human eye नहीं देख सकती. If you use complete, if you take complete 255, 255, it's become complete white. और white के आगे फिर हमारी आंख किसी चीज को visualize नहीं कर सकती. And suppose सबको मैं 0 0 कर दूं, then it's become complete black. और human eyes black के नीचे नहीं देख सकती. So complete light, complete white, and complete black. उसके आगे human has a limitation to identify the color, such that this RGB spectrum is varying from 0 to 255 only. Are you clear?
Yes, sir.
Yes, sir.
Okay. Now, if you take a pixel, suppose this is a pixel. मैं मान लो कि ये जो ब्लॉक लिया एक पिक्सल है, एक इमेज का एक पिक्सल है. So every pixel has, suppose मैं एक कलर ले लेता हूँ. Let me take any color. Okay. Okay. Just a second. Suppose I'm taking this color, right? So okay. This color. So if I see the value of red, एक pixel, there is only one pixel, but one pixel having three different value. Its R value is 255, green value is 51, and blue value is 153. That means when we talk about an image, just a second. When we talk about an image, suppose मैं एक image लेता हूँ ये वाली, उसमें कोई भी एक pixel लो, right? उस pixel के लिए मुझे 3 value मिलेंगे, which means that कि suppose मैं इसको matrix में convert करूँ, at that time there are 3 matrix: red matrix, green matrix, and blue matrix. Okay, so let me show that matrix. Okay, मैं इसको बंद करता हूँ, but window छोटा है, so I will resize this image first. Image size is 220. You can see 220 by 220. Let me reduce that image. The function called resize. It will reduce the size of image. So reduce the size of image. This key capital A. Let me take A1 is a reduced another variable, and yeah, I am resize A. So let me take any, for instance, let me take 10 by 10, 10 rows and 10 columns. So if I display this image in a matrix form, you can see three different matrices. Yeah, let me see the first image. What is the dimension of figure A and figure B? You can see that. Yeah. Let me see both the figures. Let's see. Yeah. Okay. See the image, 10 pixel. Here 220 pixel. Yeah. Here you can see the image, very small. It is resized in a 10 by 10. Okay. If you can see. अगर मैं इसको zoom करूँ 1 मिनट, zoom in. इस इतने में ही होगा. Can you see the pixels? Can you see the pixels
Yes.
of an image?
Yes, sir.
Yeah. So it is nothing but a pixel. So what is the value of that? But suppose you are taking a 1 pixel. Suppose your first pixel you are taking. So what is? Let me see in a matrix form. What is the value of first pixel? उसमें R की वैल्यू कितनी है, G की कितनी है, B की कितनी है? So yeah, so this is the matrix. So you can see that A1 is resized 10 by 10. Yeah, 10 by 10 by 3 unsigned integer 8, yani 8-bit image, and each value is varying from 0 to 255. You can see there is no such value which is beyond 255 and less than 0. See, there are three matrices, A111, this is 2 and this is 3. That means this is the first component says that all rows, all column with R1 matlab this is nothing but R component. This is nothing but B component, and this is nothing but G component. So this is R, G and B. So if I take first pixel, if I take the first pixel of image, whatever color inside that pixel, the value of R is 229, the value of G is 135 and 110. And suppose I set here कि वो कौन सा color बनेगा. So let me take 229 is R component, 135 is a green component, and 110 is a blue component. This is the color. This is the color of the pixel 1. First pixel आपका जो भी होगा उसका color ये होगा. Got it? So it's reducing. Just a second. So this is nothing but a matrix form, and I have already told you, okay, when we deal with signal processing, sound processing, or image processing, you always deal with a numerical quantities. And once you have a numerical quantities, you have to deal with mathematics. तो यहाँ पे जब आप image के साथ play करना हो, तो definitely you have to play with these numbers, and it is nothing but in a matrix form, matrix array form. Okay, so if you want to enhance the image, if you want to, if you want to play, if you want to use the, if you want to enhance the quality of image, you have to enhance the numbers, right? In such a way. So it is nothing but a matrix operation. And once you have matrix operation, I think you have already learned linear algebra. Have you learned linear algebra in your syllabus?
Yes, sir.
So linear algebra is nothing but matrix. So there are so many methods in a research work we are using, जैसे कि आपको eigenvalues. Have you heard about this one? Eigenvalues, eigenvectors.
Yes, sir, they are used in matrix only.
Okay. Okay. Have you learned neural network in your syllabus? Neural network, any artificial intelligence, AI and DS subject है ना आपका शायद course, AI-DS, artificial intelligence. तो आपने न्यूरल नेटवर्क तो शायद पढ़ा ही होगा, न्यूरल नेटवर्क. ओके.
Some algorithms of.
Some algorithm for machine learning or deep learning. So it is based on the classification purpose. The machine learning is, as far as the, there are so many applications of neural network, but one of the application is classification, object identification, robotic is, जैसे कि बोले robotic technology. So robotic technology is what? Suppose means it has to be first of all identify the object, not only identify, discriminate the object. So obviously it is not using the whole object as it is using features, like just like a principal component analysis, independent component analysis, linearly dependent analysis. There are so many features on the basis of that the object can be identified. I hope कि मैं जो बोल रहा हूँ थोड़ा सुना होगा कहीं पे. Okay, so yeah. So if you go with CNN, yani deep learning, or sorry, machine learning or deep learning, CNN, RNN, okay, then you have to use features-based classification, and the features, suppose you want to derive, you have to use eigenvalues, eigenvectors. This belongs to the linear algebra, right? Then single value decompositions, you have already learned SVD, single value decompositions, diagonalizations, LU decompositions, right? All these things are basically belongs to linear algebra. If you have a good command on linear algebra, that means if you can play with the matrix, definitely you can play with the image processing. So obviously image processing, जिसका पहले ही मैंने बोला है, those having a good command on mathematics, they can easily do much more research work in digital image processing. Actually, digital image processing is a field of mathematics, but majorly used in computer. That is why it looks like a computer version, right? So it is all about this data that you are seeing over here. I think Sheikh Alisha Fatima Muhammad, your microphone is on. Please mute it. Okay, now come to this slide. See, now suppose you want to see the R, G and B component. Suppose you want to separately display. अगर आप उसको display करना चाहो, suppose अगर उसको display करते हैं, चलो. Suppose I want to display, resize में बंद कर देता हूँ with an image. Then, if I take the size, what is the dimension of this particular image? You can say M, N, and dimension is D. Is nothing but is equal to size of A. Right. So yeah, it is M is 22, 220, N is 220, and dimension is 3. So yeah, I have already got. I'm not going to waste my time. So I am taking here. Yeah. N plus A. Okay, so here I have to separate first red component. This is not A, all rows, all column 1 that we have already seen. This is your green component of A, and this is the blue component of A. Now what I have to do, I have to take one zero matrix of dimension Mn. So 220 by 220, I will take a 0. Now cat is a function which can concatenate the red, green and blue component. So if I want to display only red component, what I will do? I will take concatenate 3-dimensional IR. Meaning this thing I will take as only red, only the matrix of red component I will take. Remaining component I will take as a 0, 0, which means that, suppose, can you see this? If I take 255 only red component, and if I take remaining all are 0, it's become a complete red. Are you clear?
Yes, sir.
Okay. So
Yes,
in
sir.
this form, what I will doing? I'm taking red component, yani only A matrix of red component, and remaining two, green and blue, I'm taking all zeros. Suppose I want to display your green component image, then I will take red and blue as 0 and green as matrix A. Similarly for blue. And suppose I want to display all three together, so I am using subplot, or individually भी आप कर सकते हो. Let me see. See this image. Let me see the original image as well. Yeah, you can see. This is the original color image, and every color image with three components: red, green, and blue. If you take this summation RGB together, you will get this image. Are you clear?
Yes, sir.
Yes, sir. Yes, sir.
Okay. And this three matrix is nothing but, you can see that. Just a second. Yeah, these are the three matrix, and there is no such value beyond 255 and less than 0. Okay, so these three matrix you are using as a red, green, and blue component. Okay, and suppose again you want to concatenate all these three. Again, if you concatenate IR, IG, and IB, you will get the original image. The function called CAT, CAT, and 3 is the dimension. And if you use IR, IG, and IB, that means red component, green component, blue component, you will again get the original image. Okay. Right. Now, generally, in some cases, when you go for color kind of thing, you really need the object having color. Then you have to use RGB 1 by 1. You have to perform, because the always analysis is particularly performed on a matrix, single matrix, right? So you have to take 1 by 1 RGB. And suppose you are using artificial intelligence neural network or whatever, and suppose you need a color as a feature, then definitely you have to use RGB. Suppose in some analysis you are least bothered about the color, you are just you are just interested in the object, whether it is a colorful or whether it is not. So in that situation, suppose आपको एक ऑब्जेक्ट को आइडेंटिफाई करना है. सपोज इट इज अ चेयर. जरूर नहीं कि मुझे वो चेक करना है कि ब्लू चेयर है, ग्रीन चेयर है, या कुछ येलो चेयर है, या कौन सा कलर है चेयर का. इट डजंट मैटर. आई वांट टू जस्ट आइडेंटिफाई व्हाट इज द ऑब्जेक्ट. इट इज जस्ट अ चेयर. द शेप सेज दैट इट इज अ चेयर. Least concern about color. At that time, we are not interested in R, G, and B, all three matrix. We are interested in one matrix. So how we can use that one matrix? Okay. So in that situation, we convert our RGB color image into form of gray image. So the conversion is RGB gray image. And what is the relation of between RGB pixel value and gray value pixel? So gray is nothing but the value is varying from 0 to 255. There is only one matrix such that it is either 0, that means completely black, and 255, that means completely white. And whatever in between value, which is called as a gray value. Are you clear with what is gray value?
Yes, sir. We can say grayscale.
Okay, grayscale. Suppose एक पिक्सल है जिसका कोई वैल्यू है. सपोज उसमें रेड कंपोनेंट है, रेड वैल्यू इज समथिंग, ग्रीन वैल्यू इज समथिंग, ब्लू वैल्यू इज समथिंग. इफ यू मल्टीप्लाई द रेड वैल्यू ऑफ दैट पिक्सल विद 0.2989, जैसे कि यहाँ पे आया है YIQ कलर स्पेस, You know that NTSC color system television, even color system आपको पता है, NTSC color system, which is following YIQ color space, where Y is indicated as a luminance grayscale value, Q is indicated as I is indicated as a orange blue, and Q is a purple. And if you take the relation between RGB and YIQ color space, then there is a weighted matrix over here. So we are interested in only Y. So you obviously definitely YIQ become inverse. आपको पता है मैथमेटिक्स फिर से A inverse into B. So this matrix, if you take this matrix on left hand side, it's become this matrix inverse into RGB. So we are interested in Y. So first of all, let me take the inverse of a matrix. Linear algebra you have already learned. उसमें आपको inverse find करना पड़ेगा. So you have find the inverse of this matrix, and the inverse of this matrix is something like this. Okay. Now if you take Y, we are not interested in I and Q with RGB. We are interested in Y component, yani gray component. The coefficient says that it 0.2989 into R matrix multiplication plus 0.5870 into green plus 0.1140 into B. That means if you want to convert a RGB pixel value into gray value, you multiply your R with 0.2989 and summation green with this, and with this you definitely convert a gray value, right, which is again varying from 0 to 255. कोएफिशिएंट ऐसे है कि इसका समेशन ना तो 255 के ऊपर जाएगा यानी मैक्सिमम 255 होगा या तो मिनिमम 0 होगा. So these coefficients are very much important. So if you display this image, it is again a gray. There is only one matrix, and this matrix having same dimensions remain same as it is, but the value is varying from 0 to 255 only. Any doubt, anyone? Okay. So now we are not going to multiply one by one each and every matrix, every pixel value by this coefficient. There is a ready-made function in MATLAB called, suppose I am writing A gray. Let me take a variable. Okay, and the function says that RGB to gray. It will definitely convert the value of बैकग्राउंड में फंक्शन में वही फॉर्म होगा जो हमारा मैट्रिक्स में कोएफिशिएंट्स बोला. ईच एंड एवरी पिक्सल से इस तरह से हो सकता है. So if I convert this image from RGB to gray, and if I display this image, you can see the image. Okay, are you clear?
Yes, sir.
Now, कहीं पे आपने देखा, आपने भी डील किया है इसके साथ. Have you remember? अगर आप इस चीज के साथ डील करते हो, किसी को कुछ रिकॉग्नाइज या रिकॉल हो रहा है तो बोल सकता है. कहीं पे आपने ऐसा किया है?
Yes, sir. In the bedtime mode of Android mobiles,
Correct.
there is an option.
करेक्ट. कैमरा में ऑप्शन होता है आपके पास अलग अलग. यू कैन सी देयर आर सम फीचर्स अवेलेबल कि सामने ऑब्जेक्ट आपको कलरफुल दिख रहा है, लेकिन सपोज अब तो ट्रेंड चल गया है, सब कलर में देख रहे हैं, तो मुझे अल्ट्रा एचडी ब्लैक कलर में ब्लैक एंड व्हाइट यानी ग्रे इमेज कैप्चर करना है, और वो अच्छी लगती है, ऐसा नहीं है. कलर से कई बार अच्छी आपकी ग्रे इमेज भी लग सकती है, राइट. सो अगर आप वो इफेक्ट जो आप बोलते हो, इफेक्ट आपका जो सेटिंग में जाओगे आप इफेक्ट्स में, मोबाइल की मैं बात कर रहा हूँ, वहां पे आप जो ब्लैक एंड व्हाइट या अल्ट्रा ब्लैक व्हाइट अगर सिलेक्ट करोगे तो देखो आपका कैमरा जो सेंसर है वो ब्लैक एंड व्हाइट सेंसर नहीं है. आपका कलर जो कैमरा में कलर सेंसर है वो तो कलर को कैप्चर कर रहे हैं. तो आप कैमरा में जब इमेज अगर आप किसी का फोटो खींच रहे हो वो तो कलरफुल आ रहा है, लेकिन जब मोबाइल की स्क्रीन पर डिस्प्ले हो रहा है दैट इज योर ब्लैक एंड व्हाइट. Are you clear what I'm saying?
Yes, sir.
Yes, sir.
तो
Yes, sir.
वो कैसे हो रहा है? तो देर इज एन आरजीबी टू ग्रे फंक्शन. व्हाट काइंड ऑफ फंक्शन? एंड्रॉइड हैविंग डिफरेंट प्लेटफॉर्म हैविंग डिफरेंट फंक्शन, बट ऑपरेशन इज परफॉर्म लाइक दिस. चाहे आप कोई भी ले लो मैथमेटिकल टूल, मैं आपको ये बता रहा हूँ, आप चाहे कोई भी सॉफ्टवेयर ले लो एंड्रॉइड में, सपोज आपके जो भी प्लेटफॉर्म होंगे उसमें मैटलैब नहीं है, कुछ और है, वट एवर है, बट फंक्शंस मैथमेटिक जो ये दिख रहा है, मैं जो कोएफिशिएंट दिखा रहा हूँ, 0.2989 इंटू आर, 0.5870 इंटू जी एंड 0.1140 इंटू बी, बैकग्राउंड में तो आपको यही कोडिंग करना पड़ेगा, वेदर यू गो विथ एंड्रॉइड प्लेटफॉर्म और विंडोज प्लेटफॉर्म और आईएसओ प्लेटफॉर्म, whatever application or tool you are using, you have to code. When you suppose you want to code your program, you have to use this relation only, right? और ये रिलेशन कैसे आया? विद द कलर्स, रिलेशन बिटवीन कलर स्पेस ऑफ आरजीबी एंड वाईआईक्यू एनटीएससी. ओके, सो दिस इज द बैकग्राउंड ऑफ, मतलब बैकग्राउंड में मैथमेटिक्स ही चल रहा है, डिस्प्ले भले आपको कंप्यूटर विजन में दिख रहा है. ओके, सो दिस इज कॉल्ड आरजीबी टू ग्रे कन्वर्जन. एंड इफ सपोज अगर मैं इसको ओपन कर दूं, दैट मीन्स कि वो पिक्सल कैसे आएगा? लेट मी रन दिस ए ग्रे इमेज. ओके, लेट मी रिसाइज फर्स्ट. मैं यहाँ पे A1 कर देता हूँ, so that the whole matrix can be visualized. Yeah. Just a second. Yeah, you can see the gray image is nothing but it is only one matrix, 10 by 10. If you see in a color here, A gray having dimension 10 by 10, there is no 3 dimension, only one dimension. There is no 3 color component, only one color component with unsigned integer 8. That means the value is varying from 0 to 55. So once when I convert this color image into gray image, it has in a single matrix. So when you are not interested in the color component during your analysis, you are just interested in the structure or dimension or shape of the object, you are just interested in that feature only, definitely in place of using 3 matrix, you have to deal with only 1 matrix. अगर कलर के साथ करना है तो आपको करना क्या है? One process, you have to repeat a process 3 times. R के लिए जो करोगे same G, same B, process तो वही रहेगी, लेकिन 3 times you have to perform the process, which means that it taking much processing time, much memory consumption. Otherwise, nothing more than that. Are you clear?
Yes, sir.
Okay. So today we are talking about only gray image. मैं color की बात नहीं कर रहा हूँ. So whatever image enhancement we are going to perform on gray image. अगर आपको color में perform करना हो तो आपको 3 बार perform करके बाद फिर merge करना पड़ेगा. Okay. So yeah. Let me come to the main point. So this is called RGB to gray conversion of an image as well as in a matrix form. Now we are talking about error. Error in image. Generally the name, there are 2 types of error. One is called, now we are, again I'm repeating, we are talking about now gray image only, because whatever concept we are going to discuss only on 1 matrix. आप उसको 3 में करना चाहो तो 1 by 1 RGB 3 matrix individual लेके you can perform it. Now there are 2 types of error in image. One is saturation, second is noise. Saturation, that means what? White spot. Image के अंदर white spot आ जाते हैं. And noise means what? Dark spot आ जाना image के अंदर. अब my question is, किसी इमेज के अंदर व्हाइट स्पॉट कब आ जाता है? You have observed and you have experienced this particular noise, saturation noise. Anybody? Hello? When you capture an image through your mobile or camera, when you will have a white spot in your image, or you can say the image is washed out.
So very much part of light is being
करेक्ट लाइट के
intensified.
सामने एग्जैक्टली सो जब भी आप सेल्फी खींचते हो तो आपको पता है कि लाइट आपके ऊपर गिरनी चाहिए, यानी कि एग्जैक्ट लाइट के ऑपोजिट डायरेक्शन में आप अपना कैमरा रखोगे। कैमरे के ऊपर लाइट नहीं गिरनी चाहिए, लाइट ऑब्जेक्ट के ऊपर गिरनी चाहिए। लेकिन सम टाइम व्हाट हैपेंस कि हाई लाइट में हम लोग, हमारे पास एंगल है ही नहीं, वी हैव टू कैप्चर योर इमेज इन द लाइट इज कमिंग ऑन कैमरा एंड यू हैव टू कैप्चर बिकॉज देयर इज नो अदर एंगल इज अवेलेबल। एट दैट सिचुएशन अगर आप कैप्चर करके देखना, यू विल हैव अ वाइट स्पॉट ऑन योर इमेज, दैट इज कॉल्ड अ सैचुरेशन, मतलब हाई अमाउंट ऑफ लाइट। मैंने बोला ना मैक्सिमम वाइट मतलब आपका बन जाएगा 255। और ब्लैक स्पॉट कब आ जाते हैं इमेज के ऊपर? ब्लैक स्पॉट
No light is being falling upon it at all, like that.
no light, no, it's okay, it's okay, not no light, less amount of light is coming in your camera. You can try in a very, when the sun is set, या फिर in a room light, there is no such much high amount of light. When you use your selfie or camera, you have a, there's some black and white kind of spots in your on your image. That is called a noise. In a low, when the light is very low and suppose you capture image, you can see the image is having definitely a noise. Name of the particular noise is salt and pepper, and how it will be reduced, which will be discussed later on. अगर गलती से कैमरा एंगल सेट ही नहीं हो रहा है and you have to capture the image in low light, then how you can enhance that image, how you can remove that noise. There are some method available in this image processing through which you can remove that image noise, and you can very good image. जैसे फोटोशॉप वगैरह रेडीमेड सॉफ्टवेयर है, GUI बेस है ये। ओके ओके now so yeah, no black spot yani you have a noise and a noise error, and white spot on an image, then you have a saturation noise. How it can be overcome we will discuss later. Okay, now image sampling and quantization, I'm not going inside much because interpolation. Interpolation, what is the role of interpolation? If we talk about the image interpolation, okay, right. जनरली आपने देखा शादी में ये ट्रेंड चल रहा है, इवन कई बार हम लोग पोस्टर भी बना देते हैं। वी हैव अ स्मॉल साइज ऑफ इमेज, राइट, वी हैव अ स्मॉल साइज ऑफ इमेज, पासपोर्ट साइज फोटो है आपका सपोज, and suppose you want to enlarge that image and want to make a big poster, कैसे करोगे? हेलो, yes everyone, suppose you have a passport size photo and suppose you want to enlarge it and want to make a big poster kind of picture, what you will do without losing quality?
Sir, if the current pixels of the RGB of original image are suppose lesser, or we can say 1 into times, then we can make all those pixels or the elements of the matrix 3 into or 4 into times, so that
No.
it
If you multiply 255 is multiplied by 2, then what is the pixel value? Suppose 100 है, 200 है, suppose the pixel value is 200, and suppose you want to multiply this pixel value 200 by 2, what the pixel value becomes?
yes sir, it will go beyond, it will
Beyond 250. It is white, it's a complete white. If you go to beyond 255, it's a white, so your image become white. So you cannot multiply pixel by 2 times or 3 times. Then another option,
Sir, we increase pixels.
there. Okay, very good. Who is this? Prajwal. Prajwal. Yes,
Yes.
Prajwal. Increase pixel having two concept. Number one concept. सपोज दैट पिक्सल इज हैविंग साइज 1 सेंटीमीटर, मैं सेंटीमीटर की बात कर रहा हूँ, एक्स फॉर एग्जाम्पल, इतना होता नहीं है बट एक्स फॉर एग्जाम्पल, सपोज दैट पिक्सल साइज इज 1 सेंटीमीटर by 1 सेंटीमीटर. So what you are going to do, you make it bigger, 2 centimeter by 2 centimeter, 4 centimeter by 4 centimeter. You are talking about this in this sense.
सर वी कैन डू दैट बट मतलब हम वर्चुअल से पिक्सल भी डाल सकते हैं एआई की मतलब से
Okay.
यूज से.
आप, that means you are talking about, suppose the image is 10 pixel by 10 pixel, right? यानी total 100 pixel in your image.
यस सर.
And you suppose want to add more pixel, यानी उसको 200 pixel by sorry 20 by 20 का कर रहे हैं, मतलब you are adding another 100 pixels, ऐसा बोल रहे
यस
हो?
सर. यस
Okay,
सर.
but if you add some pixel, what will be its color? उसका कलर क्या रहेगा? अगर मैं सीधा ऐड कर दूंगा ब्लैक ब्लैक तो सभी जगह डॉट डॉट आ जाएगा, अगर मैं सीधा ऐड कर दूंगा व्हाइट व्हाइट तो सभी जगह व्हाइट स्पॉट आ जाएगी, बिकॉज नॉइज विल बी एडेड. तो किस तरह से ऐड करेंगे उसको, उसका कलर क्या
सर
रहेगा?
वो उनके पास के पिक्सल्स के कलर से थोड़ा सा मैच होने वाला कलर.
Okay, very good. Exactly right, Prajwal. Excellent. Okay, so there are two concepts. If you increase the size of pixel, यानी कि अगर आपने देखा होगा कि एक छोटा सा पिक्चर आपने कहीं पे लिया फोटोशॉप में, या फिर सपोज यू आर टेकिंग इन अ वर्ड फाइल, एंड सपोज इफ यू इंक्रीज इट्स डायमेंशन, उसको जूम करोगे, जूम इन एक्चुअली क्या करो, अगर इफ यू जूम इन मतलब पिक्सल 10 by 10 की इमेज है, एंड सपोज यू इंक्रीज द साइज ऑफ पिक्सल, पिक्सल फट जाएंगे, आपका इमेज में पिक्सल्स दिखने लग जाएंगे इन प्लेस ऑफ ऑब्जेक्ट. ऐसा होता है ना, व्हेन यू जूम इन द इमेज पिक्सल दिखने लग जाते हैं.
यस सर.
जैसे कि मैंने आगे दिखा है वो इमेज में लीना में कि पिक्सल्स दिखने लग जाते हैं, करेक्ट ना? ओके, लेकिन इसलिए प्रज्वल ने सही बोला कि इन प्लेस ऑफ इंक्रीजिंग द साइज ऑफ पिक्सल वी हैव टू ऐड सम पिक्सल्स. But once if we add the pixels, what kind of color they have? So Prajwal says that let we had the neighborhood colors of that particular pixel. Yeah, exactly. So these neighborhood colors you are going to take, which is known as interpolation. और मैथमेटिक्स में न्यूमेरिकल एनालिसिस आप पढ़े हो? Have you learned numerical analysis subject? Somewhat. So उसमें आपने दो चीज पढ़ी होगी, इंटरपोलेशन एंड एक्स्ट्रापोलेशन, न्यूटन्स फॉरवर्ड डिफरेंस फार्मूला, न्यूटन बैकवर्ड डिफरेंस फार्मूला, समथिंग लाइक दैट, राइट? सो इंटरपोलेशन का मतलब ये होता है, व्हाट इज द मीनिंग ऑफ इंटरपोलेशन? इंटरपोलेशन दैट मींस समथिंग इज मिसिंग इन अ रेंज. अगर आपकी रेंज 1 to 10 है एंड सम वैल्यू 5 से 5 7 9 आर मिसिंग इन बिटवीन द रेंज. So with the use of this range value, remaining value in that range, you are filling that value of 5, 7 or 9. And this is the concept of interpolation. So in this situation, suppose in image, if you want to increase or enlarge the image, you are adding some pixels. And once you adding some pixels, you have to fill up that pixel with the colors. But किस colors है? Neighborhood colors. There are some methods. First method is nearest neighborhood interpolation method. Second is bilinear interpolation method. Third one is bicubic interpolation method. So generally, these are the methods which are used. These are the methods which are used to enlarge the image. Photoshop, GIMP, this kind of software is a GUI based software. So आप तो drag and drop करोगे. What you will do? You will drag and drop the particular object. So in that situation, what kind of operation is performing behind that particular drag and drop situation, you never know. But there is some interpolation formula is working on the pixel value, something like this. Okay, so here you can example, you can see A is a 72 dpi, यानी 213 by 160 pixel. उसको अगर मैं zoom करता हूं तो you know is a and zoomed back to the original size, nearest neighborhood interpolation formula. Then B is the shrinked image by the zoomed using bilinear interpolation से उसको किया है. C C is the same, but using bicubic interpolation formula. And D2 have same series sinking down 150 dpi instead of 70 dpi. So if you use this kind of, just a second. Okay, so this is called image enlarging, right, with the use of interpolation formula. Okay, now we are talking about intensity transformation and spatial filter. So here we are using some of the concept. First is contrast stretching function and thresholding function. Okay, so let me have an example. I'm not going mathematically, because there are so many concepts of mathematics. But let me take an example through. You will get better idea. Okay, transform the following image performing the thresholding from threshold gray level value 80. That means what? Suppose you want to convert an image into black and white kind of form by putting some threshold value. Suppose we are taking an image of pixels 4 by 4 for an example, having value 70, 120, something like this. If I display as an image, you can see the color. So if it is near 255, it's a complete black. If it is, a complete white. If it is near 0, it is a complete black. So here I have displayed this pixel value in the form of image, something like this. Okay. Now suppose we will take a thresholding function, thresholding value k is equal to 80. And the function is thresholding. Thresholding function says that if the value, condition says that if the value r is greater than 80. Now, see, there are two concepts. One, suppose you want to make it complete black and white, right? या फिर suppose you want to make it grayscale, but highest gray and lowest gray value. So if I take 120, maximum pixel value of this image is 120, right? Okay. So how many bits are required to convert this image into binary form? Okay, maximum 120 है. 120 को बाइनरी फॉर्म में कन्वर्ट करने के लिए कितने बिट्स मुझे चाहिए? Yes, anybody?
So minimum 8 and max 32 bits.
8 तो 256 के लिए चाहिए. अगर मेरा 120 है तो 2 raised to 8 is 256. Okay, 2 raised to 5 32, 2 raised to 6 64. Correct? 2 raised to 7 128.
128. Yes.
Correct? Yani 7 bit is enough. 7 bit is enough to cover,
yes,
to convert this.
Yes,
okay, correct. Yeah. So what I am setting that, suppose this is my L. So obviously we will start with 0. So L is nothing but 2 raised to 7 yani 128. So maximum अपना होगा 127 yani L minus 1. So I am taking L minus 1, maximum is 127. and minimum is 0. This means that if I using this kind of function, then definitely if I use 80 is my threshold value, the function says that if suppose the pixel value is less than or equal to 80, अगर वो 80 या 80 से कम हुआ तो वो उसको 0 में कन्वर्ट कर देगा. And suppose if it is greater than 80, then it is converted into maximum 127 because this is a 7-bit image, so maximum होगा 127. Are you clear? अगर 127 की जगह मैं लिख दूं 255 तो complete black हो जाएगा, but it is not required over here. Okay, so this function, the calculation says that, see, if I apply this condition over here, you can see that n is equal to 7, l is equal to 2 raised to n, 2 raised to 7 yani 128, right? And l minus 1 yani 127. So the range of the grayscale value is between 0 to 127. So here you can see 70. If I pass this function according to condition S, 70 is less than 80 such that it becomes 0. 120 is less than 120 is greater than 80, so it's become 127 and so on. And if I display this image, this image is looking like this, right? This is called thresholding of an image. Now this is just an example, but if we apply this concept on image, original image, then what happened? Okay. I'm taking this code that we have already written. Okay, so okay, Lena, and this is okay. Now here you can see that if you are we are taking the image here, maximum value is okay. It is 155 255. अगर original image link तो here you will definitely get clear cut idea. Just a second. Now suppose I see the original gray image. So here you can see the value. So in this case, your maximum value, if you observe this, it is more than 200. Some value may be 255. So here maximum value we are taking as a 255, 256. 255, that means L is equal to 255. And suppose I'm taking a thresholding value 80. This is the condition, simple condition. You can also write this condition. Okay. Capital M. Let me take this called I. Now you can see. So now I apply the thresholding value 80. Can you see this figure both?
Yes,
Yes,
sir.
sir.
Okay, this is the original gray image. I am applying the threshold value 80. That means the value of the pixel which is less than or equal to 80 becomes 0, and the value which is greater than 80 becomes 255. क्योंकि maximum अपना 255 है, right? So it's become 255. If I change the different threshold value, suppose I will take 100, 120, कम भी ले सकते, 60, 120, 200. Some 200 is too much high. 180. If I'm taking 5 different threshold value, मैंने कोड इसलिए बनाया कि चलो एक साथ सब परफॉर्म हो जाए. So if I perform all together, you can see this window. Okay, so now if you use threshold value, then your image becomes different. So threshold value 60, thresholding true, you are converting the image in the form of black and white. See, here the thresholding maximum is 255, minimum is 0. Yani whatever pixel value, you are either 0 or 255. That means the pixel value is completely black or completely white. Are you clear?
Yes, sir.
That is why the image is black and white. Now, for a different threshold value, you have a different kind of threshold value. More, agar threshold, if you can see less threshold value. If I use 60, is a threshold value. That means what? 60 and below 60 pixel values are converted into black, and more than 60 pixel value become white. So in this situation, the white space is much more as compared to the black. Okay, so there are many white pixel and more white pixels and less black pixels, such that this images look like a white space. In another case, see, if you take 180, threshold value is 180, if you set, then the value which is less than or equal to 180, there are so many values having less than or equal to 180 value are converted into black. That means 0, that means a black. And few values having more than 180 pixel value, they are converted into white. So if you can definitely set the different k value, and you can change the appearance of an image depend upon what is your requirement. Suppose you are analyzing something, and suppose you want a feature. Suppose you want a principal component analysis or independent component analysis, and then there are so many features you want to extract. But before extracting those features, जैसे कि मैं आपको एक बात बोलूं, lifeline यानी the lines palmistry. Do you know the palmistry? हस्तरेखा, हस्तरेखा विद्या, अपनी लाइफ लाइन और बहुत सारी लाइन्स आर अवेलेबल इन आवर palm, right? Suppose you want to analyze, your research topic is palmistry, and some of the line you want to predict, and you are going to using the astrology given by the Indians, and suppose you want to take your palmistry decision on the basis of the image captured by you of a particular palm of a particular person. In that situation, what is the most important thing in palm? If I want to use palmistry, what is the most important thing of palm?
So the different lines.
Lines. So what is your features? You are taking features as lines. You are much more interested in lines. You are not interested in what is the size, what is the color of the palm. No, you are not interested in this. You are much more interested in lines. So if you take a picture of palm, suppose, and if you convert in this image, if you convert in a gray image, you are not interested in the whole gray image. You are interested in lines only. At that time, what you will do? You remaining portion should be either black and line should be white, या फिर your line should be black, remaining portion should be white, because you are interested in lines only. So you perform a pre-image processing before going to detection of or separation of the lines. Okay, one of the algorithm is Canny algorithm, age detection. You can go with it. Age detection, Canny algorithm is most widely used, which can separate your lines from the palm, and you can use that features for the classification. Neural network se jao, genetics se jao, ya fuzzy jao, any other classification. Simple, you can use the distance formula, cosine distance formula, sine distance formula. You can use so many correlation and classify your line. Right. So suppose this is about all about line. Suppose जैसे गणेश जी का हम लोग स्केच ड्रॉ करते हैं, तो आपको पता है गणेश जी का स्केच, अगर मैंने एक स्केच ड्रॉ किया, सपोज इफ यू वांट टू आइडेंटिफाई व्हाट ऑब्जेक्ट इट इज, सो यू नीड ओनली लाइंस. इफ यू ड्रॉ अ लाइंस, आपको पता है ऐसे इमेजेस भी आते हैं जिसमें सिर्फ लाइंस ही होता है, एंड ऑन द बेसिस ऑफ लाइन यू आइडेंटिफाई दिस ऑब्जेक्ट इज ऑफ गणेश जी, दिस ऑब्जेक्ट इज ऑफ हनुमान जी, राइट? नॉट ओनली दिस, on animal structures you have already have lines only. So on the basis of only lines you can identify the object. This object is this one. So suppose you are using a machine learning concept in which your target is to identify the object, discriminate the object. So why you are taking the whole photograph, yani color image with three, whole shape, dimension, each and every things you are taking and going for the processing, it take a lot of time, and ultimate output is what? This is just a dog, this is a parrot, this is a cow only. So if you want to identify that object, no need to go with the whole big RGB color photograph. You can use as a feature just a line, a diagram of this object, and you can identify. So आपकी जो प्रोसेसिंग टाइम होगा या मेमोरी कंजम्पशन होगा, इट विल बी रिड्यूस इफ यू यूज. और जब फीचर एज्यूम करना हो, फीचर को आइडेंटिफाई करना हो, सो सपोज यू आर गोइंग टू यूज कैनी एल्गोरिथम टू आइडेंटिफाई ओनली एजेस दिस को डिटेक्ट करना हो, तो व्हाई यू आर यूजिंग दिस ग्रे इमेज? इन प्लेस ऑफ ग्रे इमेज लेट वी प्री प्रोसेस द इमेज. एक तो आरजीबी टू ग्रे किया, दिस इज वन ऑफ द प्री प्रोसेस. फिर ग्रे में से आपने उसको ब्लैक एंड व्हाइट में किया, ताकि थ्रेशोल्ड वैल्यू सेट करके अपीयरेंस आपने ऐसा किया कि यू कैन क्लियर कट आइडेंटिफाई द लाइंस. सो इट विल हेल्प इन अ फीचर एक्सट्रैक्शन, एंड वंस यू हैव अ बेटर फीचर्स, योर क्लासिफिकेशंस बिकम मोस्ट इजियर. यानी न्यूरल नेटवर्क और मशीन लर्निंग को बहुत इजी पड़ेगा, एंड वेरी शॉर्ट पीरियड ऑफ टाइम द मशीन आइडेंटिफाई द ऑब्जेक्ट. जैसे हमारे पास तो ब्रेन है, ह्यूमन ब्रेन, वी हैव अ सुपर कंप्यूटर. ऑब्जेक्ट देख के ही बोल देते हैं दिस इज काउ, दिस इज पैरट, राइट, दिस इज चेयर, दिस इज फैन. पर इतनी प्रोसेसिंग, इतनी ही स्पीड अगर आपको अपने मशीन लर्निंग या रोबोट को देनी है, then you have to perform this image processing concept behind. Are you getting my point?
Yes sir.
So आगे चल के जब फीचर एक्सट्रैक्ट करोगे आर्टिफिशियल इंटेलिजेंस में, before classification, suppose you want a features, you need pre-processing of image and this is why this pre-processing images are very much useful, and there are so many things you can do with the use of thresholding. Now thresholding is converting the image into either 0 and 1. Now the next concept is different transformations, like image negative. Sometimes you need negative image, that CT scan karte hai, x-ray karte hai, x-ray image, filmography karte hai, you need negative images. Even in your mobile you can convert your whole system of mobile into negative form. वहां पे already display में setting में है, it is converted into negative image. So some of the decision is taken from the negative images. You have to transform your original image to negative. जैसे MRI करते हैं वगैरह करते हैं, उसमें negative images लेते हैं. Maybe another application, it is a medical application. You have so many other applications in which you have to use negative image. Okay. Sometimes you are using thermal image, right? You know the thermal image?
Yes, sir. The army uses it in like thermal binders for locating the enemies.
Exactly. The remote sensing, the area is called remote sensing, especially IIT, sorry, ISRO Dehradun is working on remote sensing. One of my students was selected for the dissertation from integrated MSc mathematics in ISRO Dehradun. They basically working on remote sensing area, in which the through the satellite image they have to identify the objects. First is object, then on the surface of earth, then in which they using the thermal image also. Suppose they want to find fuel, they want to find water, they want to find hills, greeneries, buildings. Okay, so even the heat, they want to suppose find the heat over or heat waves on earth, particular region of earth, they have to use thermal image. Generally animal eyes, mostly animal, cat, dog, they have any animal having capacity to identify, even snake, thermal image. They always feel the heat. Their eyes are not seeing जो हम लोग देखते वो नहीं देखते, they see the thermal image of an image. आपने पिक्चर देखा होगा प्रेडिएटर में भी, have you seen the series of Predator? हेलो, प्रेडिएटर मूवी देखिए, प्रेडिएटर में प्रेडिएटर,
Yes, sir.
उसमें वो थर्मल इमेज देखता है वो बंदा, बिकॉज ही इज एन एनिमल. ओके. हमारे इंडियंस में वो नागिन पिक्चर में दिखाते वो वो नागिन की आंखों से दिखाते विजन, उसको थर्मल सब दिखता है. इतना भी क्लियर कट नहीं थर्मल इमेज दिखा दे, बट इट्स लुक लाइक थर्मल इमेज, बिकॉज जो फ्रेम कैप्चर कर रहा है डायरेक्टर, उसको कन्वर्ट करना पड़ेगा उस फ्रेम को नेगेटिव इमेज में और थर्मल इमेज में. ओके, फाइन. देन अनदर इज अ लॉग ट्रांसफॉर्मेशन, nth root transformation, nth power transformation, inverse log transformation. See the transformation, if you see the graph, अगर आप ग्राफ देखोगे तो बहुत सारा आपको समझ में आएगा, but we will go to the direct concept, image negative. Okay, now negative image. So what is the concept? The negative image is nothing but highest intensity में से अगर मैं 0 to 255 ले रहा हूं तो पिक्सल वैल्यू को माइनस करना है. जैसे कि अगर 0 to 255 अगर मेरी इमेज है, सपोज आई हैव 100 पिक्सल वैल्यू 100, तो नेगेटिव इमेज में वो कितनी होनी चाहिए? 255 माइनस 100 यानी 155.
155.
करेक्ट. सो नेगेटिव का मतलब ये होता है कि हाईएस्ट इंटेंसिटी में से आप अपनी पिक्सल वैल्यू को माइनस कर दो. दैट इज अ मैथमेटिकल बेसिक mathematical difference formula. So here I am taking an image. Maximum value of this image pixel value is how much? 63. Here it is 63 is the maximum pixel value. Correct? Okay. How many bits required?
6 bits approx.
Approximately. 2 raised to 6 is 64. So I am taking 6 L minus 1, yani 63. It's okay. So 6, this is called 6-bit image. This is 6-bit image. So if I convert from original to negative form, so I will take maximum 63 minus R, yani its particular pixel value. So obviously every zero value is converted into 63 minus 0, yani 63. If the pixel value is 10, it is converted from 63 minus 10, yani 53, and so on. And suppose the pixel value is 63, it will be converted into 0. That means the graph becomes exact negative. See, this is a negative slope of the line, right? So this is a negative image. Now, if this image is converted into negative form, something like this. If it is a complete black, here it became complete white. Here it is, suppose if we talk about 0 to 255, if it's 255, it's become 0, and if it is 0, it's become 255. So it's a completely negative image. Are you clear?
Yes, sir.
Okay, so let me take negative image. Yeah, it's a very simple formula. So maximum L is 255. Image negative is nothing but what L minus 1 यानी 255 minus image I, directly I जो हमारी image है कौन सी लीना वाली gray image, it is directly converted in image negative and we will display as a image negative. अब क्वेश्चन थोड़ा मुझे यहाँ पे डीप में थोड़ा जाना पड़ेगा. You are performing here some mathematical operation. जब मैथमेटिकल ऑपरेशन आप परफॉर्म करते हो तो वो अनसाइन इंटीजर वैल्यू 8 होती है ना, उसको कन्वर्ट कर देता है डबल के अंदर. डबल यानी इट इज अ वैल्यू वेरिंग इन डेसिमल फॉर्म आल्सो एंड फ्रैक्शनल फॉर्म आल्सो. बट जब हम इमेज डिस्प्ले करते हैं तो इमेज हमारी ऑलवेज 8 बीट में होती है, तो मुझे ऑब्वियसली इसको कन्वर्ट करना पड़ेगा अनसाइन इंटीजर 8 फॉर्म में. Do you know about double, unsigned integer 8, unsigned integer 64? शायद another language जावा या उसमें आया होगा.
Yes, sir. Those are the data types.
So,
Data types ना. Okay, so our when you want to see the image you have to convert into unsigned integer 8. अगर मैं उसको डबल में ही रखूंगा तो वो completely white ही देगा. So here I am using unsigned integer 8 as a image such that you can be visualized. So simple, I am taking I as an image, right? I am taking L is a 256 maximum. I am converting into negative L minus 1 and 255 minus I, and you will get the answer of negative image. See the negative image. Can you see this negative image?
Yes, sir.
ओके अब आपके मोबाइल में कलर नेगेटिव इमेज आती है तो ऑब्वियसली हम लोग क्या कर सकते हैं, आर जी बी तीनों को अगर 1 by 1 अप्लाई करके अगर नेगेटिव में स्टोर करूं और तीनों को कंबाइन कर लूं तो मुझे कलर नेगेटिव इमेज मिल जाएगी. ओके, लेट मी परफॉर्म. I'm taking the color image. Okay, and I have to perform 3 times. So I will take in a for loop. For I is equal to या फिर हाँ so image negative I'm just storing that image negative. Sorry. Right. And here I'm taking L minus 1 minus I of all rows, all columns and 1. Sorry, I. यानी कि 1 by 1 component लेगा. I'm storing it in a I negative variable. Okay. Now, if I run it, I will get I negative of 1, 2, and 3. 3 component I will get of R, G, and B. Now I want to let me take a variable I negative is equal to, let me concatenate them, yani let me combine them. Is of I negative of 1, two, and 3. It will be combined, and now we will see the negative image. If I perform 3 times and combine them, I will get the image negative. 1 minute. 1 minute. Error of bracket. See, can you see this color image negative?
Yes, sir.
Yes, sir.
Okay, so if you want to perform the color negative in color image, on color image, nothing more than that, you have to perform 3 times. The R component individually, G component individually, and B component individually, and then whatever output you are getting, you have to concatenate or you have to combine them with the use of cat function. So you will get the negative color image. So obviously there is a feature in your mobile display setting में जाओगे display setting and in display setting you can convert उसमें आप होगा RGB. You are selecting RGB. See, by default it is RGB such that your mobile, the whole system, whole theme is working in RGB form. But suppose अगर आप वहां पे RGB की जगह नेगेटिव सिलेक्ट कर लोगे, so पूरा मोबाइल आपका जितनी भी है, all the whole theme is converted into negative image. So पूरा appearance negative बन जाएगा आपका. Are you clear? So this feature is also available in this. Even in your camera, once you select the effect negative, फोटो आप भले वो कैप्चर करोगे, but when you see it, ऑब्जेक्ट आप कलर नहीं कैप्चर करोगे, but it is converted into negative. So your display is negative color image. आपके पास होगा मोबाइल कैमरा में, स्मार्टफोन में अवेलेबल है नेगेटिव इमेज कैप्चर करना. Is it clear everyone?
Yes,
Yes,
sir.
Okay, so negative image एक तो रिमोट सेंसिंग में इससे एप्लीकेशन इज रिमोट सेंसिंग नंबर 1. दूसरी जगह कहां आपने देखा है नेगेटिव इमेज को?
sir. On the reels of old cameras.
Okay, I'm talking about application. यानी कि one of the application is मतलब film shooting or videography. Okay, second, next. Medical application, right?
Yes, sir. X-rays and all.
एग्जैक्ट नहीं, एक्सरे सी मैंने बोला ना, एक्सरे इज नॉट आरजीबी, देयर इज अ फ्रीक्वेंसी. एक्सरे का मशीन होता है, कैमरे थ्रू एक्सरे नहीं ले सकते आप, बिकॉज योर कैमरा हैज नो कैपेसिटी टू थ्रो द एक्सरे, बिकॉज देयर इज नो फ्रीक्वेंसी अवेलेबल इन कैमरा. मैंने वो विजिबल स्पेक्ट्रम आपको बताया ना, एक्सरे अलग ही होता है, उसकी फ्रीक्वेंसी अलग होती है. तो हमारा इंडिविजुअल, हमारा ये मोबाइल और जो कैमरा है वो इट इज नॉट एप्लीकेबल. अब फोटोग्राफी एक्सरे किसी का लेना तो अपने मोबाइल से नहीं ले सकते, इसलिए उसकी फ्रीक्वेंसी अलग होती है और आपको उस मशीन के सामने खड़े रखते हैं, उसके बाद एक्सरे लिया जाता है बोन्स का. सिमिलरली आप अगर आगे देखो, अलग तरह के रेज आते हैं जो आपको फिर आपका सीटी स्कैन करने के लिए, एमआरआई करने के लिए यूज होता है, राइट? वो उसकी फ्रीक्वेंसी अलग होती है, तब जाके वो डेप्थ तक कैप्चर कर सकता है. सो if we use this negative image in medical, you have many more applications. So pre-processing is always useful before going to the research. Now, Swati madam, how much time I have? Hello? Hello? So daily, how much time you have in for a session? 2 hours or more than that?
Yes, sir. You can continue, sir. No issues.
Okay.
Yeah.
Up to what? मतलब कब तक? अब बोलो मुझे, तब तक मैं उस हिसाब से शेड्यूल सेट करूँ.
On your call, sir.
Okay.
Yeah.
Okay, so here one of the applications, medical application, here the an original digital mammogram image is given, and this mammogram is having cancer, a breast cancer example is there. Here the white spots indicate the cancer in the breast. Okay, so if you want to find the exact cells, so obviously this white on the basis of background image, in place of that, suppose you have black dots on the basis of the white background, you can have much more idea. So in this situation, what will happen? See, this is the medical application. So what you are converting your image, you are converting your black portion into white and white portion into black, such that you can see the wonderful, clear cut idea about the cancer cells available in a breast, right? So this is medical application is useful. So I have already done it, how it will be converted negative. So I think I have to skip it. Okay. Now log transformation, one of the most and very important tool is log transformation. Sometime what happens, suppose you have a function in a hall, you see auditorium hall mein you have a function, and on the stage, that stage has only light and audience has lights are off. In that situation, suppose you are capturing photo or there is low light on a stage and you are capturing a photo. Yeah, stage resolution is very much clear because there is a light spotted on a stage. So every object on a stage is available. But at the same time, you have a, one task. You have to also capture a photo of audience as well. Because आपको कहीं पे रखना है कि this many audience are also available in this particular program. What happened? क्योंकि लाइट ऑन नहीं करोगे हॉल में, करेक्ट, और आपने फोटो कैप्चर कर लिया.
Yes, sir.
What happened in this situation? कोई दिखेगा नहीं, nobody is visible, राइट ना. और विजिबल भी होगे तो बहुत रेयरली, मतलब उसका विजुअल इफेक्ट बहुत कम होगा. यू कैन नॉट आइडेंटिफाई इवन पर्सन. और आपको पोस्टर में डालना है कि ये है. So some of the situation where you have very dark image, that means objects are very much, concealed or hidden into the background. Background में इतना चला जाता है ऑब्जेक्ट कि बैकग्राउंड हावी हो जाता है फोरग्राउंड के ऊपर. So you need a details. At that time, log transformations are very much useful. Simple formula है. The output image C is nothing but, S is nothing but, C is a controlling parameter. You can set different value of C. Log of 1 plus input pixel value R. So whatever input pixel value you have, if you take with 1 plus and if you take log on it, you will get a logarithm transformation. And logarithm transformation says that if you see the graph says that, so 0 to, suppose total pixel value intensity is 0 to L minus 1, यानी कि 0 to 255 यहाँ पे है, 0 to 255 यहाँ पे, ऐसा मान लो. L minus 1 यानी 255. So 0 to 255 is here, 0 to 255 here. लॉग ट्रांसफॉर्म ये बोल रहा है कि जितना लो इंटेंसिटी वैल्यू होगी, मतलब जितना कम होगा, L by 4 यानी 256 का अगर मैं 4 हिस्से में डिवाइड कर दूं, तो यानी 25% ओनली, ऑलमोस्ट 0 to 60 आसपास, 60 to 65, मतलब those pixel having 0 to 260 to 65 जितनी 264, 0 to 264 pixel value, they are very much dark, obviously बहुत dark होगा. So if you take log transform, see the line, the graph of log, see the 0 to L by 4 converted into 0 to 3 times L by 4, यानी उसको 75% ऑलमोस्ट, यहाँ अगर 25% को 75% तक वो इंक्रीज कर देगा उसकी पिक्सल वैल्यू, यानी डार्क पिक्सल होंगे वो लाइटर बन जाएंगे, करेक्ट. देन व्हाट अबाउट लाइटर, जो लाइट में होंगे जो पिक्सल, वो भी लाइट हो गया तो आउट ऑफ बाउंड्री चला जाएगा. सो नो, L by 4 to L minus 1 यानी ऑलमोस्ट 64 65 से लेके 255, राइट, अगर मैं लूं तो उसको भी इंक्रीज करेगा, लेकिन इतना ज्यादा इंक्रीज नहीं करेगा जितना लोअर पिक्सल वैल्यू को इंक्रीज करता है. यानी कि डार्क को लाइट करेगा, लेकिन लाइट को इतना नहीं लाइट करेगा कि फिर वो विजिबल में ना हो. So this is the form of logarithmic transformation. So log transformation is very much important. In such case, you want a detailed information. Let me take an example. See the example of matrix 0, 50, 30 and 180. Here 0 is 0, but here 50 become 180, 30 become 157. And see, the image is very dark, becomes very light. What is C value? The C value is, you can take any value, but according to this formula, if you take maximum divided by 1 plus log this, you will get 45.9 AC. If you set C is equal to 45, you will get a better appearance. Okay, see this example. Left side original gray image. See, details are not that much visible. But if you perform a log transform over here, you can see the clarity of this particular image detailing. Are you clear?
Yes, sir.
Okay, so if you see this one application I have already discussed, if the detailed information is not, detailed information is concealed into the background, in such a situation, suppose you want that detailed information, you have to use log transformation. Just like I have given an example of photography of your event during in particular auditorium hall. ओके दूसरी कोई एप्लीकेशन बता सकता है जब मुझे डिटेल इंफॉर्मेशन चाहिए तब कहाँ यूज करोगे व्हेन वी गेट अ डिटेल इंफॉर्मेशन अबाउट फ्रॉम द इमेज
Sir, we can say that the people who study coins, old coins. So if they
Okay.
want to, if they want to know the year of that coin, if that
exactly number one number two anybody else डिटेल्स चाहिए डिटेल्स हैव यू हर्ड द वर्ड जूलिया ओके डिजाइनिंग में जाता है ओके फाइन जनरली फॉरेंसिक लैब पता है ना फॉरेंसिक स्टडी
yes, sir, related to crime.
हाँ एक कई लोग काम करते हैं अलग अलग चीज से आपकी अगर आईज की डिटेलिंग चाहिए आपके फिंगरप्रिंट की डिटेलिंग चाहिए तो बहुत सारी ऐसे उसमें डिटेल्स इंफॉर्मेशन चाहिए व्हेन यू हैव अ कैप्चर मान लो कि आपने फिंगरप्रिंट ले ली सबकी क्लियर कट नहीं आई व्हाट यू विल डू you have to perform pre-image processing. This is the research. Pre-image processing, first you make it details, make it visible clearly. एक ये application है forensic lab में, right? Number one, number two,
So
number three.
fossils, we can say.
Yeah, exactly. Even when you go for microbiology kind of thing, when they work on cells of particular pieces, cell level पे काम करते हैं microbiology. डीएमएलटी करते हैं माइक्रोबायोलॉजी करते हैं ना वो लोग डिटेल में माइक्रोस्कोपिक इमेज पे काम करते हैं राइट एट दैट टाइम दे नीड दिस काइंड ऑफ क्लियर कट पैटर्न ऑफ द ऑब्जेक्ट नॉट ओनली दैट केमिस्ट्री डू यू नो द केमिस्ट्री बॉन्डिंग द बॉन्ड्स पे काम करते हैं स्ट्रक्चर इलेक्ट्रॉन फिजिक्स केमिस्ट्री इलेक्ट्रॉन न्यूट्रॉन प्रोटॉन उसके ऊपर पहुंच जाते हैं वहां पर आयोनिक बॉन्ड देखते हैं एट दैट टाइम यू नीड this kind of analysis. Not only that, if you go to astronomy, यानी स्पेस में देखोगे तो when you capture image, बहुत डार्क इमेज आपको मिलेगी. इवन टेलीस्कोपिक इमेज व्हेन यू टेक अ टेलीस्कोपिक इमेज यानी अर्थ से लेके ऊपर लोगे या ऊपर से लेके नीचे लोगे यानी सैटेलाइट थ्रू इमेज लोगे तो अर्थ की लोगे लेकिन अर्थ पे से अगर ऊपर की इमेज ली then you need a detailed information at that time if it is not clear cut vision you can use log transformation as a pre-processing to enhance the image for more details okay are you clear
Yes, sir.
one of the more important thing is gamma correction this is widely used gamma correction so here gamma correction formula is what simply r raised to gamma yani power function आप वैल्यू ऐड करोगे इफ यू टेक गामा इज इक्वल टू 1 ओरिजिनल इमेज एज इट इज रहेगी बट जैसे जैसे आप गामा की वैल्यू गामा की वैल्यू जैसे जैसे इंक्रीज करोगे ना पावर में इंटेंसिव वैल्यू ग्राफ देखो नीचे जा रहा है डाउन जा रहा है डाउन आउटपुट आपका डाउन जा रहा है मतलब इमेज डार्क बनेगी एंड सपोज यू इंक्रीज द गामा वैल्यू योर इमेज बिकम्स लाइटर so I'm not going inside the mathematical formulas but what is the application see there is a two application when the image is dark suppose you want it wash out and second time your image is wash out image suppose you want it to be dark first example is medical MRI of fracture of human spine की MRI image है one image is captured उसमें fracture है fracture here but image is too much dark it is not clearly visible right so before they generate the image for medication or for the diagnosis and suppose they want to give this image to doctor before that what they will do they will use pre-processing यानी gamma correction करेंगे राइट, क्योंकि वो लैब अलग होती है, डॉक्टर अलग होता है. सो लेबोरेटरी पर्सन, व्हाट अ लेबोरेटरी पर्सन विल डू, suppose it is very dark, he has captured a photo of line and it is very dark, it is not clearly visible to exactly where the fracture is there, how much fracture is there, so it need to be improved, that means usko lighter karna hai. So what they are performing, see, if they use gamma is equal to 0.6 value, yani power c into पिक्सल वैल्यू रेस टू 0.6, तो वो क्या हो रहा है, सी लाइटर बन रहा है, और ग्रामा वैल्यू डाउन कर रहे हैं 0.6. अगर मैं एक्जैक्टली 1 रखता ना, r इज इक्वल टू 1, तो जो ओरिजिनल इमेज है वही मिल रही. और सपोज आई रिड्यूसिंग द गामा वैल्यू बिकॉज आई वांट अ लाइटर इमेज. सी, आई एम रिड्यूसिंग द गामा वैल्यू सो दैट द पिक्सल वैल्यू इज गोइंग हाई, राइट. सो हियर सपोज, okay, so I'm reducing the gamma value so it's become lighter. कहां तक जाना है, it's depend upon visibility, it's depend upon decision maker कि मुझे यहाँ पे clear cut vision दिख रहा है, yes this is enough for me, so I will set gamma is equal to 0.3 and I will transfer this image back to washout image, right. Now this is dark to light, this is one of the option. Second is washout image can be converted into dark image. लॉग ट्रांसफॉर्मेशन वहां पे नहीं कर सकता, लेकिन यहाँ पे उल्टा भी कर सकता है. मैंने आपको बोला था ना कि when suppose there is no such angle available, right, to capture a proper image, you have to capture in that situation whatever angle you have, and suppose the light is coming on your camera and in front of light you are capturing the image of an object, always it is a washout image, always it is a washout image. और washout image हो उसको डार्क विजिबिलिटी नहीं होगी. अब तो हमारा हम लोग यूज कर लगे ड्रोन इमेजेस, है ना. few maybe you may have drawn, someone has a drone, they are using drone for capturing aerial image. So obviously there is a function, there is a celebration, on ground celebration is going on your college ground, like any festival on ground, and someone has a drone and they are using drone for the aerial image, okay. But it's a midday, almost 12 o'clock or 12 or 1 o'clock or 2 o'clock, and there is too much light, and some of the amount of light is coming on drone and you are capturing the image, your all images are washout image. So once you have captured a washout image, a function is over at 2 o'clock, right, and you have captured lot of images and all images are washout images, how you will rectify it? With the use of gamma correction. See the visualization. If you increase the gamma value 3.0 sorry 3.0, the washout image become little bit darker. 4.0 it's become more visible. If you take 5.0 it's more visible. Excuse me. Okay, so as per your requirement, you can increase or decrease the gamma value and you can perform a gamma correction on this particular object to enhance the image in spatial domain. Are you clear with gamma value, gamma correction?
Yes, sir. So there is an application cam scanner. It also.
Yeah. Inbuilt, but it is GUI based. You cannot control whatever ready-made features are given. You have to use. But suppose you want 100% control in your head. Totally sorry to say, but generally ऐसा होता है कि कंप्यूटर जनरली बीटेक, एमटेक, MSc-IT, हमारे यहाँ भी MSc-IT या MCA people generally if they do the research work, they are using ready-made function or ready-made feature of a software. They have not made their own code. तो होता क्या है, whatever ready-made features or ready-made command or functions are given, they have to do this way. But हमारे students जब maths में ऐसा होता है, जब we always prefer our own function. हम अपना फंक्शन खुद बनाते हैं. That means 100% control हमारे हाथ में रहता है. If I gamma function is already, if I can see, I can show you. मैटलैब में ऑलरेडी गामा फंक्शन है, आई एम एडजस्ट फंक्शन लिखो, आपको फटाफट मिल जाएगा. बट दे हैव कंट्रोल, द 100% कंट्रोल इन योर, नॉट इन योर हैंड. अगर आपने खुद का बनाया है तो 100% कंट्रोल आपके हाथ में है. इवन यू कैन इंप्रूव, सॉफ्टवेयर ने जो बनाया है उससे भी आगे जाके आप उसको इंप्रूव कर सकते हो. दिस इज द मेन एडवांटेज. इसलिए हमारे स्टूडेंट जब डिसर्टेशन वगैरह करते हैं मास्टर डिग्री, दे ऑलवेज, इवन जेनेटिक एल्गोरिथम, इवन न्यूरल नेटवर्क भी हमारा खुद का होता है. कस्टमाइज न्यूरल नेटवर्क, कस्टमाइज न्यूरल नेटवर्क, सब कुछ हमारे हाथ में रहता है. We always develop, even practical भी हमारे सेल्फ ही हो रहा है. हम रेडीमेड फंक्शन हम अलाउ ही नहीं करते स्टूडेंट को, बिकॉज 100% कंट्रोल हमारे हाथ में रहेगा, तभी आप कुछ नया कर पाओगे. आर यू गेटिंग माई पॉइंट?
Yes, sir. Sir, an example I given. Yeah.
हाँ. आप पाइथन यूज करते हो, रेडीमेड लाइब्रेरीज आर गिवन, उसमें जो अवेलेबिलिटी है वही करना पड़ेगा. समझना है?
Yes, sir. We have no control. Understanding. Sir. Yeah.
तो फिर रिसर्च करने में प्रॉब्लम करेगा कि रिसर्च में तो सिचुएशन ऐसी होती होगी कि ऐसी सिचुएशन आ गई जो आपके सॉफ्टवेयर के साथ मैच ना करे. यू हैव टू मॉडिफाई द कमांड. हाउ यू विल मॉडिफाई? सॉफ्टवेयर विल नॉट अलाउ यू. ओके ओके.
Yes, yes.
ओके. चलो, कॉन्ट्रास्ट स्ट्रेचिंग फंक्शन मोस्ट इंपोर्टेंट में मैं चला जाता हूँ फटाफट, क्योंकि बिकॉज लीनियर ट्रांसफॉर्मेशन, इंटेंसिटी ट्रांसफॉर्मेशन. एक इंपॉर्टेंट चीज है जो मैं आपको, बिट प्लेन, बिट्स अलग करना, बिट्स प्लेन, एक ये मैं आपको डिस्कस करूंगा बिकॉज इट्स वेरी इंपॉर्टेंट. ओके, बिट, जस्ट अ सेकंड. Okay. One of the most important concept is B-spline, piecewise linear transformation function, यानी bit plane slicing. Bit plane slicing अगर मैं आपको explain करूँ little bit. Suppose this is your image. You convert this image into binary form. 4-bit image is taken. For example, 8-bit होगी तो ये सब आपके 8 bits हो जाएगी. And suppose you separate first bit plane, यानी the first value of each and every column, second, third, fourth. So 4 bits are separated, just like this. A dollar image is taken. It has a 8-bit. If I separate all 8 bits, yani this 8-bit plane, 7-bit plane, 6-bit, 5, 4, 1, 3, 2, 1. Total 8 planes are there. So if you want to store a dollar image, though it is a gray image, अगर color करोगे तो ऐसी 3 image बनेगी. So RGB image है. But if I talk about gray image, one gray image has 8 images, 8-bit plane images. And every bit plane has its own contribution. See, the original image, 8-bit gray image, in which 8-bit, 8 number of bit is a high contribution. बहुत सारे object 8-bit में है. 7th, 6th, 5th, 4th, 3, 2, and 1. So, it consumes 8-bit, that means it consumes more memory. But अगर मुझे किसी image को, बहुत सारी image, you have a huge database, and suppose you want to store that database with the less memory, or suppose when you want to perform some analysis on that image, you want to speed up your speed of this computation. No need to store all 8 bits together. If you can see, if you combine some of the image, आपको पता है बीट प्लेन को फिर से कंबाइन करके तो ओरिजिनल मिल जाता है. दिस इज एग्जांपल. बट सपोज इफ आई टेक एन एग्जांपल, this is the original image, 8-bit dollar image. This image, the first image is the nothing but a combination of 8-bit, 8-bit plus 7-bit. Yani if I take the summation of 8-bit and 7-bit, this is nothing but this kind of image. If I take 8 plus 7 plus 6, yani only 3 bits I will take, 8-bit, 7th bit and 6th bit together, I will get this appears. And if I take 8 plus 7 plus 5th plus 6th, that means I have a 8 different plane, out of which I will take the summation of only first four plane, 8, 7, 6, and 5, it is almost equivalent of the original image. So why I am storing that 8-bit image? This means what? Just a second. Why I am storing this 4, 3, 2, and 1 image bit plane? Because it's consume equal memory as 8, 7, 6, and 5 are having, right? So I can reduce the memory up to 50% if I convert my image. In place of 8-bit, I will take just 8 plus 7 plus 6 plus 5. What happened? It consumes less memory, so your database becomes, if your huge database, thousands of images you are taking for a research work, if it consumes less memory. Second thing, when you take a process, neural network kind of thing, then if you have to process each and every data set for in your training or testing purpose, it takes a lot of time, right? In place of that, if you convert your image into this kind of storage, it consumes less memory. दूसरा फायदा ये भी हो सकता है कि when you transfer your image, when you transfer, not transform, transfer your image over a network, then it consumes less memory. So it is nothing but one kind of compression. It is not exactly compression, but it is a one kind of compression of an image. Are you getting my point?
Yes, sir.
Okay, so this will help you in your research work. Okay, so this is called bit place slicing method, and one of the important is histogram equalization method. So if you see the histogram equalization for contrast enhance, मैंने आपको बोला था, suppose you want to find a face recognition system. This means suppose in your college or in your any firm, suppose you just identified a person, attendance system बना रहे हो आप लोग on the basis of the face recognition, right? So on face recognition, so you have two options. Either you match whole face with the different faces available of that particular person in your database, whole face to face. Or second is, suppose you want to take a feature of that face and match feature to feature, it becomes 90% reduced. You can reduce the 90% of the processing speed. यानी जो 100% में काम होता है वो 10% में निकल जाएगा काम आपका, right? At that time, if you want to enhance the contrast level. Contrast level का मतलब होता है foreground and background को clear cut separate करना. Object and background separate होना चाहिए, या फिर जो चीज को जैसे बोलते हैं ना focus and defocus. Focus and defocus, आपका object में discrimination होना चाहिए. This is called contrast level. Okay, so if you can see the example, if you are dark image, that means what the intensity value is varying from 0 and see you can see 0 to almost 80. All the pixel value is varying from 0 to 80. It is a low contrast image. Here again, if you see the washout image, yes, your intensity value is varying from almost 140 to 250, so high value. And suppose you have this kind of washout, this whiteness image, this is washout image, low contrast image. The intensity value is varying from almost 90 to 140. All the values are varying from 90 to 140. In all three situations, this is a low contrast image, or it is not clear-cut vision of an image. Okay, but if you take this image is nothing but pollen of a particular flower or plant. Pollen image, and this is clear-cut visible. Here you can see the pixel value. All the pixel values are varying from 0 to 255. So it is uniformly distributed. All the pixel values are uniformly distributed from 0 to 55. In such situation, your foreground and background are clear-cut discriminated, and such that you have very much clear-cut high contrast image. So sometimes suppose you want to make your image high contrast, then how you can which mathematical method you can apply such that you can have a high contrast image. I'm not going inside this mathematical stuff, monotonic increasing function, but I'm giving you an example, something like here. See, if I use histogram equalization, inbuilt function is HISTEQ. It is a histogram equalization function ready-made available in MATLAB, or you can perform formula. So histogram equalization whether the image, it will convert it into high contrast image, and you can see the diagram. Okay. So gamma correction, log transformation, histogram equalization, these are the very essential pre-processing or image enhancement technique in special domain